All right, now we're going to be graphing an inequality with the equation of a line. So when we have a situation like this, so you have a equation or an inequality that represents a line, we want to solve for y first. So if y is already solved for, we're one step ahead. We're going to take our slope and our y-intercept, and we're going to graph it like it was a line. The only difference is when it is greater than or equal to, and that is a less than or equal to, or greater than or equal to sign. And that's what we have here. I know it's not that clear, but it's a less than or equal to sign. The line is solid. If it's a greater than or less than, the line is dotted. All right, so that's one of the two differences between graphing a line and graphing an inequality, is that you have to make a determination whether the line is going to be solid or dotted. But once we've done that, we use slope and y-intercept, and we graph a line like we normally would with an equal sign. Your y-intercept is 1, my slope is 1/3, so up 1 over 3, down 1, left 3, and we draw the line. Shading, I'm a big fan of plugging in 0, 0. And it's never shading up or down, it's always towards 0, 0 or away from 0, 0. If I plug 0, 0 into this equation, I get 0 is less than 1/3 times 0 plus 1. So I end up with 0 is less than 1, and that's a true statement. So we're going to shade toward the 0, 0. In this one right here, I have to solve for y first. So I subtract 5x on both sides, I divide 3 on both sides, and I get y is greater than negative 5/3 x plus 4. My slope is negative 5/3, my y-intercept is 4, so I start at my 4, I go up 5, left 3, down 5, right 3, down 5, right 3. And I plug 0, 0 in for the shading part. Now, if you notice, it's a greater than sign, so it's a dotted line, once again. But I plug that 0, 0 in for the shaded part. 5 times 0 plus 3 times 0 is 0. We get 0 is greater than 12. Well, that's false. So we shade away from the 0, 0 point.